Good evening, everyone. Welcome to the programming workshop of RoboISM. I am Abdullah. So let's start the workshop. Uh, Robot programming is the process of development of a control scheme for how a machine interacts with its environment and achieve its goal. Now, what is programming? In general, programming is the process of creating a set of instructions that tells a computer how to perform a task. Or we can say in layman terms that the program is the way to communicate with a machine. Next slide. So, which language do robot understands? So robots or in general a computer system don't understand languages like English or Hindi. Computers only understand zeros and ones. So programming is the language of computer. We can say that uh, programming any machine to instruct the computer to perform a task. Let's say we say add to number and show me the result or display my name on screen. So how will we tell the machine to do these things? How will the computer understand my instruction? So as we know, it doesn't understand the languages we speak like English or Hindi. So well, we have to learn programming language to make the computer understand it. And it's very easy to learn programming language. So we humans, we can write the high level language code, and the compiler then converts the high level language into low level language which is understandable by the machine. This is how the robot understands what we instruct it. So between there is a compiler which converts that. So let's say technically what a compiler is. So as you can see on the screen, there is an image which shows we sent a source program to the compiler, and the compiler first check if there is an error present in that code, and if there is an error, it returns an error message, and then it gives it to the target program to do further. So compiler is a computer software that translates or compiles the source code written in high level language, let's say C, C++ or Java, into set of machine level language and instruction that can be understood by a digital computer's CPU. Compilers are a very large program which handle error checking and other abilities. So now let's learn how to program the Arduino. So where we will write our code, the program that we have to write, we use Android Arduino IDE to write our code. But what is an IDE? IDE stands for Integrated Development Environment. Integrated Development Environment, it is a software for building applications that combine common developer tool into a single graphical user interface. Or simply we can say it is a tool that combines our code and then it executes. So this is how an Arduino IDE looks like. We will learn more about it later. In this PPT, we have attached two videos which have the instructions how to install an Arduino software into your machine. This PPT will be provided to you, which you can later refer to it and install Arduino IDE in your system. Next slide. So this is the Arduino program structure. There are basically three parts in the Arduino program. First is the declaration part, where you have to declare the variables and the functions. Now second comes the void setup part. Void setup part is which you have to set the pin modes. That part runs only one, and why after powering the Arduino board it runs only one. And the third part is the void loop part. This is the main body of the program where you have to give the instructions to the Arduino. As the name suggests, it runs again and again in a never ending loop. And this is the structure of the simple Arduino program. You will learn more about it later. And this is from my side. Now you will be learning basics of programming by Ayushman sir. Thank you.
Yeah, so good evening, everyone. My name is Ayushman. So till now, you have been become familiar with the basics of what is programming, what is the importance of programming in robotics. So let me first ask you a question: that how many of you have at least some prior experience in any of the programming languages? Like it may be C++, Python, Java, anything. You can write yes or no in the chat box so that we can have an idea about. Yeah. So have there are many yes out there. Okay. Yeah, so it's good. Yeah. So many of you have at least some knowledge in programming. Yeah, it's all right. Yeah. So we'll touch upon the basics first because some of you also don't have any prior experience. So let's in this section of basics of programming, we'll study about data types, variables, functions, and operators, etc. So moving on to our first topic, data types. Next slide. Yeah. So data types, as its name indicates, it specifies the type of data stored, right? So it represents a type of data which you can process using your computer program. We use data types to declare constants or variables. So they, in the next slide, you'll see that there are some common data types which are available in Arduino IDE. Yeah. So this table shows some common data types. On the left hand side, you can see Boolean, int, long, char, float, double, and the description shows the type of values that they store. Okay, the Boolean stores the truth values, int and long stores integer values, and char stores characters, and float and double store real numbers. So you may be thinking, what is the difference between int and long if they are storing the same integer numbers? So the difference lies in the range of the values that they can store, or the storage size you can see in the right hand section of the table. Okay, so these were some common data types which are available in Arduino IDE, and and one link is given in the downside. If you can see, you can later refer to this link and you can see in depth what are the various other data types which are present. So in the next slide, we'll see about constants. So constant, as its name again indicates, that it is a value that cannot be altered by the program during normal execution. That is, the value of a constant is the value of a constant defined is the same throughout the program. If you define a constant in a program, then the value will remain the same throughout the program. And if you will try to change the value, it will throw out an error. Okay. So as we have already discussed that there are different data types. So these data types are used to define these constant. Like constant have different data types: integer, floating point, characters. Okay, so you can see it is mentioned over here. And how can we define these constants? So we can define these constants by using const keyword or hash define keyword. Okay, so for numeric and string constants, but for defining constant arrays, we have to use const keyword. So like an example is given. If you define constant named pi. So you have to write const float pi is equal to 3.14. Okay. And you can ask your doubts in the chat section, and at the end of the session, you can will allow you to unmute and ask your questions. Yeah, so we just saw how to define user-defined constants. Okay, but there are some built-in constants also in the Arduino IDE. So there are basically three types of built-in constants. Yeah, they are used to define logical levels, for defining pin levels, and for defining pin modes. So logical levels, there are two types of constants, true and false. False corresponds to 0 and true corresponds to 1 or any non-zero value. and the pin levels correspond to high and low. These pin level high and low is used when you are using the digital write function, which we'll study later, to define the pin level of a digital pin, okay, output. And the pin mode is used to define if a pin is an input pin or an output pin, okay. In the next slide, we'll study about the ASCII. Now, what is ASCII? Some of you might have heard about this. ASCII is an abbreviation for American Standard Code for Information Interchange. Now, it is a character encoding standard for electronic communication, and it encodes 128 specified characters into 7-bit binary integers. And every character is given a specific integer value. And in the next slide, you'll see there's a table which shows the ASCII values of different letters, different alphabets, or special characters, or some keywords which are there. So there are ASCII values in decimal, hexadecimal, and octal format. So these ASCII values are used by us while writing programs. Okay. And in the next slide, you'll see some common ASCII values which are used in our common day-to-day writing of a program. So these are mentioned here for your ready reference. Like the \0 stands for the null character, and its value ASCII code is 0. And the digits are ASCII ranges from 48 to 57. The capital letters range from 65 to 90, and the small letters range from 97 to 122. Okay. Now let us see what are the main parts of a typical program. So in the next slide, you will see that there are two main parts of any program. One is variables that basically store the data, and the other part is about functions which manipulate the data which are stored in variables. The variables can be considered as a box or a container which are storing values. Okay, and functions can be considered as a piece of code that helps us to reuse a certain piece of code and to use it efficiently, like a machine. You input a thing and then it processes and then outputs it. So that's a function. And now coming back to variables. So as mentioned earlier, variables are like boxes. Okay, and then here it is mentioned how to declare a variable. So for declaring a variable, we first write the data type, then followed by the name of the variable. Like example is given, if you are defining an integer variable named temp, you will write int temp. And then you can also give the value of a variable, like you can define a variable while declaring. So you can write int while using the equal to operator. So you can write int temp is equal to 8, or you can define it later on, like int temp and then temp is equal to 8. Okay, and then as soon as you declare a variable, the compiler will give a memory block to that variable. Okay, and on the right hand side, you can see a visual representation of the same thing which we have discussed. Like a variable can be considered as a box, and then a value is being stored in that. Now, continuing about variables, why is the name variable given to it? So the name is given because the values in a variable can change. Okay, so it can be considered as a box, and then you are assigning a value to that box, and then you can replace that value with another value. Like you can see 4 is assigned, and then you can replace it with 5, and the code for that is given on the right hand side, like int minum is equal to 4, and then you are writing some pieces of code, and then after that you are again reassigning a value of 5 to that variable. Okay, so this is possible in variables and not constants. Yeah, so as mentioned earlier, while declaring a variable, you have to give a name to that variable. But certain rules and conventions are to be followed while naming a variable. Like variable names are case sensitive. Like if you give a name capital A is equal to 3 and small a is equal to 3, then they are different variables. They cannot be considered the same. Also, the variable name is a combination of alphabets, digits, and special characters that include only 2 special characters, underscore and $sign. The third rule is that variable name cannot begin with a digit. It should begin with an alphabet or a special character. And then it should not be a keyword. Now, what is a keyword? Keyword are reserved words which are used by the compiler to portray something else. They are pre-reserved so they cannot be used as a variable name. Okay. And then it is usually suggested to avoid beginning a variable name with a double underscore, because it is used in some internal changes, internal uses. So they are usually avoided in a variable name. Okay. And in the bottom side, you can see some examples of valid and invalid variable names are given. And in the invalid side, you can see int, float, char. These all are invalid because these are keywords. These are reserved words which are used to declare some data types. Okay. So that's why. Now moving on forward, we see that a visual representation of the representation that different variables, different data types store different types of variables, like different boxes are given. The int box is storing only int value. The real box is storing only real values. The character variable stores only character values, and string stores strings. Okay, so this is what is portrayed here in this slide. And in the next slide, we see that how are constants stored? How can we represent constants like this? So if we place 4 into a box and permanently seal that box so that it cannot be changed in the execution of program. Like if you store a value in that box and then you seal that box completely, like you cannot take that value, replace it with something else. So that is what constant constitutes. Okay. So this is it from my side. And if you have some questions, you can raise your hands. So we'll unmute you. Okay, so I guess there are no such questions. So I would like to, okay, there's a question.
Hello, sir.
Yeah,
Please explain, sir. ASCII, sir.
Yeah, ASCII.
I not understood, sir.
Can we go back to that slide, Shashwat? ASCII is just a character encoding system. Okay, you are representing different characters like alphabets, numbers, special characters. It is a universal encoding system which is used. Like if you declare a variable, character variable, then it will store that value in the form of ASCII code. It will have an ASCII code and it will save in that form, save the value in that form, ASCII code. Okay, so in that case, ASCII codes are used.
Okay, sir. Thank you.
Yeah.
Sir, I had a question too.
Yeah, please go on.
Sir, is the language similar to any other normal language like C or C++?
Yeah, it is quite similar to C and C++.
Sir, so the keywords are the same?
Yeah, it is.
Sir, but the boxes you made before this to explain how variable store, constant store.
Yeah.
Sir, in that you wrote some keywords, my real and my car.
Just a minute.
Sir, exactly that one, the variable one.
Okay, in that there was series of boxes. Yeah. So what's your doubt?
Sir, it had written my real and my are these.
So the real values, real values are stored in float and double data type. Real values means which includes decimal point.
Okay, sir. So
Okay.
the words you were using on those boxes, they were just for the illustration, na? They are not.
Yeah, just for illustration.
Okay, sir.
Yeah. So are there any questions?
Sir, good evening, sir.
Yeah, good evening.
Sir, means in order to get into the RoboISM means which language do we have to learn and up to what extent do we have to learn? That's my question, sir.
You just have to attend these programming sessions and it will all be clear to you. Okay.
Okay, sir.
Yeah. So I guess there are no more doubts. So I'd like to call Somishri to discuss upon operators and flow of control.
Good evening, one and all present here. Myself Soumyashri, and as you all now know the basics, let's move further to know a little bit more about programming. As Ayushman already asked many of you, and you all are already familiar with one or other programming language. And even if you don't worry, you are here just to learn. So I would like to keep the session a little bit interactive. Whenever I ask you any question, don't unmute yourself, just write your answer in the chat box. So let's begin. First, we'll start with operators. There are basically three types of operators: arithmetic, comparison, and compound operators. Starting with arithmetic operators, you can see as we have 6 arithmetic operators: remainder, multiplication, addition, subtraction, division, and assignment operator. You all must have already studied about all these in mathematics, and I think the only one new for you would be the modulus operator. So the percentage symbol here is used for remainder, also known as the modulus operator. This modulus operator is what gives you the remainder. For example, if I ask you what is 15 mod 4, can any of you write the answer? Yeah, that's right. I think you all understood it. Yes, that's 3. Very good. So, and one more question, what will be 7 mod 9? We are getting different answers, 7, 0. Okay, so let me explain you. If we have 7 mod 9, so 7 is less than 9. So if this is all less than 9, that we get 7 as the answer. For example, if I ask you 3 mod 4, 3 is less than 4, so we'll always get 3 as the answer. I think it's clear. So moving on, rest, addition, subtraction, multiplication, division, and I think all of you must have studied these, and I don't need to explain it further. So next is the assignment operator. So why assignment is marked as important, you'll get to know once we move further. So next comes up the comparison operator. So there are 6 comparison operators as well. Not equal to, less than or equal to, double equal to, greater than or equal to. So in mathematics, for greater than equal to, you always used to make that angular face and inside that a equal to sign, right? Inside that a line. So just remember here we use this angular and after that an equal to sign. So and remember in the last slide we used the assignment operator as single equal to, and here we use double equal to. So the major difference is this, that the only single equal to is used for assignment, that is whenever you want to give a variable a value, and double equal to is used for comparison, like when you compare if a given value is equal to another value or not. For example, int a equals to 10. This is assignment where you are assigning a the value of 10. And for the use of comparison, that is double equal to, you'll have to wait a little more. We'll come up to that. Next comes the compound operator. There are 7 compound operators as shown. Compound remainder, compound multiplication, increment, compound addition, decrement, compound subtraction, and compound division. So let's see how we use it. We'll use it as an example. Suppose int a equals to 10 and we write a compound remainder equals to 5. So a compound remainder equals to 5 will be same as a equals to a mod 5. So anyone any guesses what will be the value of a when we take a equals to 10? Write your answer in the chat box. It will be the same as a equals to a mod 10. Uh, 5, 0, 0. Okay, yes. So the zeros are correct because when a equals to 10 and we write a mod equals to 5, which is equals to a mod 5. So the value of a will be 10 mod 5. That is when you divide 10 by 5, what you get as the remainder? You get 0. So yes, that's 0. Same goes for compound multiplication, division, addition, and subtraction as well. Okay, let's have one more question to see if it's clear to you or not. If we take c equals to 10, what will be the value of c minus equals to 7? Yeah, I think it's clear to you everyone now. So c minus equals to 7 will be c equals to c minus 7. And we took c as 10, so it will be 10 minus 7, that is 3. Yeah, everyone's correct. Right. So next comes the increment operator. So these are actually further divided into two types, prefix and postfix. Suppose we have I equals to 10 and we write plus plus I, that will be the prefix notation. And if we write I plus plus, that will be the postfix notation. So both do the same work, but slightly in a different manner. If you use the plus plus operator as a prefix, like if you write plus plus I, the value of I will be incremented by 1, then it will return the value. And if we use plus plus operator as a postfix, like if you write I plus plus, then the original value of I is returned first, and then the value will be incremented by 1. And same goes for decrement operators as well, just the difference is that it will decrease the value by 1. Next comes the keywords. So keywords are predefined reserved words used in programming that have special meaning to the compiler. Keywords are a part of the syntax and they cannot be used for naming. As you already know that you have been taught how to name a variable, right? So keywords, remember that keywords, you can never use keywords for naming a variable or something. Some must known keywords are int, void, float, if, break, double, and others you can see. So like int, void, float, you know that we use this to, these are just data types, we use it to give the variable our data type. So next, comments. Comments are non-executable statements which exist with the sole purpose of programmer readability. It has nothing to do with the program, right? You just write it so that you can know what, so that you can give your programmer better readability, other could understand what you have written. Now here you can even use keywords as these are completely ignored by the compiler. So the syntax for writing single line comment is shown as there, and even the multi-line comment is shown as there. Next. Next, we have the flow of control. So the order of execution of the statements in a program is known as the flow of control. This flow is implemented and controlled using control structures like sequential, selection, and repetition. So flow of control is just how you write a program, what is the order in which you write a program. So sequential is initializing variables, which you have been already taught. Next is the selection, that is different types of if statements, switch, and conditional statements, which you will just learn in this session itself. And repetition is when you do a similar thing in a loop, like when you want to do only one thing but more than once, that you do in a loop. And this also you'll learn in this session itself. Next. So next slide is the flow of control. That is, we'll start with the if else. So what is this is if inside that condition, and in curly braces you write the statement that is to be executed when it is true, and else when the condition is not true, then it goes to the else, and all the statements which are inside the curly brackets of else, that will be executed. So remember, you cannot write else without if. So and if there's only one statement, then the curly brackets may be avoided. So now we'll see it with an example. If int a equals to 20, and if a mod 2 equals 0, that is if 20 modulus 2 equals 0, it is true, right? It is 0, so it will print divisible by 2, and it will automatically come out that it will come to the this is always printed statement. So 20 mod 2 equals 0, so it is true. It will print divisible by 2, and then it will come out. It will print this is always printed. So the final output will be divisible by 2, and this is always printed. Next is the if-else-if ladder. Now, sometimes we don't have just one condition, right? We may have multiple conditions. So if you have multiple conditions, like you have first condition, you will write inside if, and whatever you want to execute, the statements inside those curly brackets. Next is the else if statements, and the next condition you will write in the else if statement, and the statement you want to be executed in those curly brackets. Remember, you can have more than one if else if statements as well. Like if you have multiple conditions, you can use multiple else if statements, like else if condition 3, else if condition 4, as many as conditions you have. And at last, when all the conditions are false, then when none of the conditions is true, then we have the else, like all are false, then it will move on to the else, and the last condition statements will be inside the else. So to know it better, we'll have an example here. Suppose int marks is 45. So we'll check if marks is greater than equals to 80. Now, is 45 greater than equal to 80? No. So we'll move on to the next condition, that is the else if statement. Now, is 45 equals greater than equal to 40? Yes, it is greater than equals to 40. So it will print B. So the output is B, and the programming will just stop here. It will not move to the else statement. Next, we have the nested if. So here we can have you have a condition, and inside that you want to check another condition. For that we use nested if. For example, if you write the condition, and if you want any statements to be executed, you write it there. And inside that, if you want to check another condition, inside one if you have the nested if statement, that is another condition, and inside that the statements you want to be executed, that is the true statements. If the condition is true, these will be executed, else we'll move to the false statements and these will be executed. And after that you can write other statements as well that you want to be executed inside the first if itself. Next. So to know nested if better, we'll just see this example. If int marks equals to 45, so we have given marks the value of 45. And now if marks is greater than equals to 80, is 45 greater than equal to 80? No. So we will move to the else if. Now 45 is greater than equal to 40, right? Now this inside this another if we have, this is known as the nested if. If marks is greater than equals to 40, we will check if marks is greater than equals to 60. So is 45 greater than equal to 60? No, 45 is not greater than equals to 60. So we'll move to the else condition, that is B minus. So the final output will be B minus. And I think this is now clear to you. Now the session is open for doubts. Raise your hands if you have any doubts. Or you can write your question even in the chat box.
Good evening, ma'am.
Yeah, say.
Ma'am, can you just go to the back, the previous slide actually, ma'am?
Which slide?
Just the previous.
This
Yeah,
one.
here, ma'am. Ma'am, here the last statement, in if only you have just introduced another like nested if, and then
Yeah.
you introduce the else. So, ma'am, I was unable to understand. At the end, the else will be what would it be of the first if, or it will be of the second if which we have
Okay.
introduced?
So here we have if and the first if, and this is the nested if, right? And
Yes, ma'am.
after that we have the else. This else is of the nested if.
Nested if.
And if we have another else inside that, that would be of the first if.
Ma'am, it should be in sequential order, like.
Yeah, it is of sequential.
Okay, ma'am. Thank you.
Any other doubt? Jinendra, you have any doubt?
No, ma'am. Sorry, ma'am. I just forgot to just go.
Okay. Any more doubts? If not, next Piyush, you can come up.
Okay, so good evening everyone. Myself Piyush Kumar Satpathy. So now let's move on to our next topic, loops. A for loop is a control flow statement for specifying iteration which allows code to be executed repeatedly. A for loop has two parts, a header specifying the iteration and a body which is executed once per iteration. The header often declares an explicit loop counter or loop variable which allows the body to know which iteration is being executed. For loops are typically used when the number of iterations is known before entering the loop. The initialization step is executed first and only once. This step allows you to declare and initialize any loop control variables. You are not required to put a statement here as long as a semicolon appears. Next, the condition is evaluated. If it is true, the body of loop is executed. If it is false, the body of the loop does not execute and the flow of control jumps to the next statement just after the for loop. After the body of the for loop executes, the flow of control jumps back up to the increment statement. This statement allows you to update any loop control variables. This statement can be left blank as long as a semicolon appears after the condition. So the condition is now evaluated again. If it is true, the loop executes and the process repeats itself. After the condition becomes false, the for loop terminates. Next. So here is an example of for loop which will iterate itself from I is equal to 1 to I is equal to 9 and terminate. First I is initialized with 1 and condition is checked, which is true, and 1 is printed. Then I is increased to 2 and the process continues till I is equal to 10. When the condition becomes false and loop terminates, it prints all the values from 1 to 9 in a single line. So next comes the while loop. So a while loop in C programming repeatedly executes a target statement as long as the given condition is true. Here statements may be a single statement or a block of statements. The condition may be an expression and true is any non-zero value. The loop iterates while the condition is true. When the condition becomes false, the program control passes to the line immediately following the loop. The key point to note is that a while loop might not execute at all. When the condition is tested and the result is false, the loop body will be skipped and the first statement after the while loop will be executed. So here is an example of while loop. The iterator I is initialized with 1 just before the loop block, and the loop will iterate till the value of I becomes 9 and will print all the values from I to 9 in a single line. So here now comes the do while loop. The do while loop is similar to while loop with one important difference. The body of do while loop is executed at least once, only then the text expression is evaluated. As it is after the loop block. If test expression is true, the body of the loop is executed again and test expression is evaluated once more. This process goes on until test expression becomes false. If test expression is false, the loop ends. So here is an example of do while loop. The loop will execute just once, even if the condition is false initially. And after one execution, the condition becomes false and the loop terminates. It will print just 1. Next. So now let's come to functions. A function is a block of code that performs a specific task. There are two types of functions: user-defined function and library functions. So user-defined function are the functions that are defined by the user to perform a specific task. When the function is invoked from any part of the program, it executes the code defined in the body of the function. Library functions are the predefined functions that are ready to use. They actually reduce our time to write a lengthy code. For example, you want to find the square root of number. Instead of writing the code, you can use just sqrt function. Next. So general structure of a function. At first, there is a return type which suggests what the function will return. It can be an integer, character, or some pointer, or even a class object. There can be functions which does not return anything. They are mentioned with void. Then comes the function name, which is the name of the function using which it is called. So after that comes the parameters inside brackets, which are the variables to hold values of arguments passed while function is called. A function may or may not contain parameter list. After that, the body of function is present. So next. So here is an example of function to find max of 3 values named max of 3. It takes 3 integer values as arguments A, B, and C. and returns an integer value. Here m variable is declared and initialized to 0, which will store the max value among 3. First, it checks whether A is greater than B and C. If it is true, it sets M as A. And then it checks for B whether it is greater than A and C. If it is true, then it sets M as B. And if both the conditions are false, which means A and B are not the greatest, it sets M as C and returns max M at the end, the max value. Next. So now let's come to the return statement. So it returns a value from a function to the calling function if desired. If nothing is to be returned, write just return at the end. If something is to be returned, write return value, the value to be returned. Here in the example, the function will return 1 if analog read function returns value greater than 400, else it will return 0 and terminate the function. Thank you. If you have any doubts, you can write in the chat box. Okay, so what is the doubt? Okay, return statement will just return a specific value which you want to print, that will be returned actually to a function which is calling it. So nothing much to explain here. If analog read function means analog read is a function, inbuilt function. So if it will return a value greater than 400, so 1 will be returned. If the condition is false, then 0 will be returned from this check sensor function to the function which is calling the check sensor function, the value will be returned.
Sir, why in parentheses you have written 0, analog read parentheses 0?
That is the pin. Pin mode means that pin is that means it will read the value from that pin. Okay. In Arduino.
Good evening everyone, my name is Pranjal. Now we will look at some basic syntax which you will use in your program. First is hash include. Hash include is used to include outside libraries in your sketch. This gives the programmer access to a large group of standard Arduino libraries or user-built libraries. Hash is called a preprocessor directive. You might wonder, what is a library? A library is a collection of precompiled routines or functions that a program can use. For example, math.h is a library which is used for including various math operations in your program. Now, let us look at hasDefine. HashDefine is a useful C++ component that allows the programmer to give a name to a constant value before the program is compiled. The compiler will rephrase references to this constant with the defined values at compile time. In general, the const keyword is preferred for defining constant and should be used instead of hasDefine. We will now look at various Arduino built-in library functions. These are very important functions that are used for controlling the Arduino board and designing it to perform various tasks. The six most important functions include pin mode, digital write, digital read, analog write, analog read, and delay function. You will learn about this function in detail in upcoming slides. Let us now look at the functions which are used for taking digital input and giving digital output to the various components attached to the 14 digital pin numbered from 0 to 13 in Arduino board. First is digital read function. It takes only one parameter, which is the pin number, whose digital value is to read. It returns a bool, which is either 1 or 0. 1 refers to high, 0 refers to low. Second is digital write function. It takes two parameters. First is pin number and second is the value that has to be assigned. Value is assigned in the format of high or low. The function does not return anything, so its return type is void. Third is pin mode function. This function is used to specify whether a pin is used for input or output, which means if a pin is connected to a sensor and we want to read the data from the sensor, then the pin mode will be an input, and if a pin is connected to a LED, then its pin mode will be output. This function takes two parameters. First is the pin number and second is the mode. Mode can be given as input, output, and input pull-up. Input pull-up effectively inverts the behavior of the input mode, where high means the sensor is off and low means the sensor is on. This function return type is also void as digital write. You can note that this function can also be used for the 6 analog pin. Let us now look at the functions which are used for taking analog input and giving analog output to the various components attached to the 6 analog pin numbered from A0 to A5 in Arduino board. First is analog read function. It takes only one parameter, which is the pin number from A0 to A5, whose analog value is to be read. It returns an integer 0 to 123 for 10 bits board like Arduino Uno, or 0 to 4095 for 12 bits board. For 10 bits Arduino board, this means that it will map the input voltages between 0 and 5 volts into integers value between 0 and 1023. This yields a resolution between reading of 5 volts divided by 1024 units of 0.0049 volts per unit. Maximum reading rate of analog read function is 10,000 times per second. Second is analog write function. It writes an analog value, that is a PWM or pulse width modulation wave, to a pin. It takes two parameters. First is pin number in Arduino Uno, and in Arduino Uno board pins 3, 5, 6, 9, 10 and 11 are the pin with PWM mode, and second is the value that has to be assigned to that pin number, and this value ranges from 0 to 255. The return type of this function is void. This function can be used to light a LED at varying brightness or drive a motor at various speeds. You do not need to call pin mode to set as an output before calling analog write. Note that analog write function has nothing to do with the analog pins or the analog read function. As we have already looked at pin mode function before, we will take a quick recap. This function is used to specify whether a pin is used for input or output. This function takes two arguments. First is the pin number and second is the mode. Now we will look at some other important Arduino functions. First is the delay function. This function delays the program by a time given by the user. This function takes only one parameter, that is the time by which the program has to be delayed. Time is given in milliseconds. This function does not return anything. Next is millis function. This function is used to tell the number of milliseconds passed since the Arduino board began running the current program. This number will overflow, that is, go back to 0 after approximately 50 days. Return type of this function is unsigned long data type. Now we will look at some math function that can be performed by Arduino boards. These functions are included with the math.h built-in library. First is the absolute function. This function returns the absolute value of an integer. Second is the map function. This is a very important function. This function remap an integer number from one range to another range. This function takes 5 parameters. First is the value which is to be mapped. Second and third are parameters are from low and from high respectively. They represent the lower and upper bound of the current range. Fourth and fifth parameter are too low and too high respectively. They represent the lower and upper bound of the value's target range. Next is the max function. This function returns the maximum number out of the two numbers which are passed to it as parameter. Similarly, there is a minimum function. This function returns the minimum number out of the two numbers which are passed to it as parameter. Next is the power function. This function calculates the value of a number raised to a power. Power function can be used to raise a number to a fractional power. Both base and power can be float values. This function returns in double data type. Now, can any one of you tell me what will be the value of power 2, 5? You can write your answer in the chat box. Yes, you are right. It will be 32. Next, square root function. As the name suggests, this function is used to call the square root of the number. This function takes any data type as input and returns a double data type. This is all from my side. Now, if you have any question, you can raise your hand or put your question in the chat box.
So please explain for base power again. How we got 32 that power?
It's a very simple function. It calculates power like we used to. So 2, if we send power 2, 5, it will calculate 2 raised to power 5. So the answer will be 32.
Yes, sir, got it.
Any more question?
Yes, sir. Sir,
yes. Ask.
There were some codes which had two values, like they took the pin and then the value. So
Yes.
we separate them by underscore or comma?
By comma, like in general functions we do.
Okay, sir.
Now we have a simulation lined in for you which will help you in your understanding.
Is my screen visible?
Yes.
Okay, so hello everyone, I am Shreyansh Jain and I will be continuing the session. Okay, so till now what you have learned is a theoretical part of programming, but programming is something which requires practical application. For the case of Arduino programming, we need an Arduino board to run the code in the real world. But right now we don't expect you to buy a board, so instead of that what we are going to do is use an online simulator WOPE, and I'm going to be demonstrating it to you right now. So I'm right now on the homepage of WOPE. Its URL is wope.com, and you don't have to install anything in it. Everything is inside the browser. It's super simple. So whenever you want to start a new project, just come here and choose your board that you want to start with. I'll be going with the Arduino Uno for now. Once we choose the board, we come to this UI. Like on the left side, you can see there is an editor where we can type our code, and on the right side, we can build our circuits. Okay, so I'll demonstrate using a small project. And to make it interesting, we will also have a problem statement. So here's the problem statement. Let's say you have a neighbor who owns a shop and he wants to install an automated door system in his shop. By an automated door system, what I mean is that whenever someone comes very close to the door, it will open, and whenever there is no one, it will just remain closed. Okay, so but the problem here is that the neighbor doesn't want to spend a lot of money on it, and he knows that you're an IITian, so he comes to you and asks you to build the system. So that's the problem statement. If it is understood by everyone, just type 1 in the chat. Okay, nice. Okay, so let's work on it. At first, before we begin, let's think about what actually we need to do. There will be a door and there will be some people standing or just walking here and there. If anyone goes near to the door, let's say closer to 50 centimeter, the door will automatically open, and if there is no one in that range, it will remain closed. So in the Arduino program, we will need the distance between the closest person and the door, and we'll need a sensor for it. We need to sense the distance. So if you recall from your previous sessions, we can use an ultrasonic distance sensor for it. Once we have the distance, we can check if it is more or less than 50 centimeter, and depending on that, we can control the door. Now to control the door, we'll also need a servo motor. And that's the basic overview of the project. Now we'll be beginning with the circuitry part first. But before we begin, how many of you guys know about the ultrasonic sensor? Just type 1 if you know about it and 0 if you don't. Okay, there are some zeros. Yeah. Okay, so I'll just show you one thing. Just a second. So I'm on the data sheet of an ultrasonic sensor. Each sensor has their own data sheet, which is like the complete documentation given by the sensor developer so that you can use. And this is an ultrasonic sensor. What it is actually it senses the distance between two objects, and it works on the principle of sonar. So what it does is first transmits some waves, waits for them to bounce and come back to the sensor, and measure the duration the whole trip took for the waves. And using this duration, we can calculate the distance. Ultrasonic sensors have 4 pins: VCC, trigger, echo, and GND, ground. VCC and ground are normal, like 5 volt and ground. I'll be explaining the trigger and the echo pin right now. Okay, so yeah, what happens is when we want the ultrasonic sensor to start sending those waves so that we can measure the duration, we'll send a trigger high pulse to the trigger pin, and that high pulse is going to be like this. The pulse width is supposed to be 10 microseconds width. Yeah, and once we send that, the ultrasonic sensor will start giving back a high pulse wave with a width equivalent to the duration it took for the waves to go and come back. So this width here we have is equivalent to the duration it took for the waves to go and come back, the whole trip. Okay, so I hope it's a bit clear now. If yes, then type 1. Yeah, so let's begin with the circuit part first. So yeah, to add a sensor, what we can do is just hit the plus button and type it here. Here we have the sensor. Okay, and like I have the VCC pin, so I'll just connect it to 5 volt at the ground, which will be here. Yeah. the trick pin, which is supposed to be an the pin that we send our pulse to, going to be. We can put it in any other pins. I'll just put it on 2, and we have the echo pin. I'll put it on 3. Okay. I also need the servo motor. So it also has 3 pins: GND, ground, V plus, VCC, and PWM through which you can control the servo motor. So ground, V plus, just a sec. I can go here. And a PWM, I can put in any PWM pin. Here 5 is empty, so I'll put it there. Okay, so this is the basic circuit part. Now let's move on to the programming part. Whenever I start, I first like to label these pin numbers, because I don't want to remember these 2, 3, and 5. So what I do is I can use hash define, and I can label these. So I have the servo pin, the PWM pin, servo pin on pin number 5. I have the trick pin, which is on 2. So 2, and pin, which is on 3. Okay. So at first we'll begin with the ultrasonic sensor part, then we'll move on to the servo motor. Okay. So before we set up anything, before we start reading and sending data through the ultrasonic sensor, what we need to do is tell Arduino which pins are meant for which purpose. We have to specify the pin modes actually. So we'll specify that, and the trick pin is used for sending the output. First we'll send the trigger to the sensor, and the echo pin is used for taking the input of the duration the whole wave took, right? So we have set up that. Now what we want to do is we want an infinite loop, and in each iteration of that loop, we want to measure the distance between the closest person and the door, and we want to check if it is higher or lower than, let's say, 50 centimeter, and based on that we want to update the state of the door, either closed or open, right? So we can use the loop function, which automatically gives us a never-ending loop. Okay, so as you remember from the data sheet, first we need to trigger that sensor, and to do that, before we do that, let's just put the trick pin on low, because as you remember, the trick pin requires a high pulse, and there might be some noise before that high pulse, which can be high too. So that might interfere with the, the whole thing, the whole communication. That's why we'll keep it low so that everything is fine, and we'll delay it. We let the loop pulse go for some time, so that the sensor understands, yeah, that is a low pulse, that is not some arbitrary stuff, and we'll delay it for 5 microseconds. You can keep it for more if you want, but I'll keep it for 5. Now we want to send the trigger pulse, and for do that we do this. Okay, we write the high to the trigger pin, which creates a high pulse, and as you remember that we needed a high pulse for about 10 microseconds, so I'll delay it for 10 microseconds, and then I'll set it back to low. Yeah, so now we have sent a high trigger pulse, as you can see. Now the sensor will start sending us a high pulse in the echo pin, and we need to measure the pulse width of that pulse to get the duration it took for the whole trip for the waves, right? So to do that, what we can do is we can use an inbuilt Arduino function called pulse in. What it does is it takes a pin number and it takes a level that you want to check for, and it searches and it checks for how much time that particular pin was on that level, and it returns that in microseconds. So what we can do is we have the echo pin, so echo pin, and we want to check it, the pulse width for the high pulse. So yeah, and we can store it in a variable int. So now we get the duration it took for the waves for the whole trip, from going from the sensor to the person and then back. Now once we have the duration, we need the distance, and to convert it into the distance, what we can do is some simple mathematics, like distance is equal to duration into speed. We can use that and do stuff, but for now I will use a formula, that is this. Why I'm not deriving this formula is because I want you guys to go and read the data sheet, because reading data sheet is very important in this industry and you need to build a habit of it. That's why after the session, just go and read the data sheet and you'll find the derivation for this formula. Okay, for now just trust me that this formula works and it will give you the distance. Okay, so once we have the distance now between the door and the closest person, what we want to do is, let's just print it first. Okay, serial.println and distance. Okay, and before we use serial, we have to also set up it at a particular frequency, and in Arduino that frequency is 9600. So now we can hit the simulation play button. It will automatically check for errors, and it will do, show us the simulation. Yeah, now I can use this slider to control the distance, and as you can see, the distance is 273 and here it is 274. It's pretty close, 1 centimeter. Yeah, we can handle that precision. We can take that precision, right? And yeah, it's pretty accurate. Yeah, it's pretty accurate. So we can just stop it for now. Okay, yeah. So we have an accurate enough distance between the person and the door. Now we want to check it. If distance is less than 50, let's say, we want to open the door. Open the door. Else, close the door. Right? To open and close, we'll need the servo motor. So let's set up that. And for the servo motor part, what we'll do is we'll use a library. And to add a library, what we do is go to the library manager, hit the plus button, and search for the library. I'm going to be using for the servo.h library, and here it is. So once I've included in the library manager, I can just include it. Servo.h. Let's talk about this library a bit. Okay. Yeah, so this library works on the concept of object-oriented programming, OOP. We are not going into details of that right now. I'm just going to give a brief overview of it. So what it does is it gives us a custom type. Like we have an int, like we can create variables like int, or it can be char or something else, right? We can create variables of different types. So the servo.h library gives us a custom type, it is servo. We create a variable of servo. Now what it means is that you can consider it that you're creating a virtual servo motor inside your code. It's not real, it's not physical, it's just programmatically defined to make our tasks easier. So yeah, in this case, A is a virtual servo motor inside our code. Now let's say we use some other library which gives us a custom type of dog, okay, and we create a, let's say, virtual dog. Similar concept. This is a servo motor, a virtual servo motor. So this is a virtual dog inside the program, not real, just inside the program. Now, in a real world, each dog has some properties, like it can bark, it has a specific color. So the virtual dog should also have those properties, right? It should also have a color. It should also have those properties. But how do we access them? We access them using a dot operator. So we type the variable name, the virtual dog. It is actually the virtual dog. We specify dot, and now we can access its properties. So let's say it's a color. It has a color, so we can access virtual dog.color. and like you can store it in a variable like string s is equal to something like this. So it will give us the virtual dog's color. Or if you want to make it bark, it will be a function, like it's an action. We want to trigger the action and it will bark. So if we can call that function using this method. Basically, you put the dot operator after a virtual object and then you can access its properties. Just name it, and if it's a function, just put this parenthesis and any arguments it needs. Okay, so this was a basic overview of OOPS, and we're not going in deep into that right now. Okay, so this virtual servo motor will also have some properties of itself, and what we'll do is we'll operate this virtual servo motors through its properties, and it will relay those tasks that we ask the virtual servo motor. It will relay those tasks to the real servo motor, so that we don't have to worry about the interfacing and everything. We can just specify, we can just tell this virtual motor that we want to do this, and it will do it for us. Okay, so to just rename it to like the servo mode, because A is a weird name. Now, if the virtual servo motor wants to relay our messages to the real servo motor, it needs the access of this pin, right? It needs to know which pin the real servo motor is connected to, so that it can control the real servo motor. So we pass in, we give it this pin using the attach function, attach property actually, and we pass in the servo pin. Now the virtual servo motors knows that this pin is for the real servo motor, and whenever we tell this servo motor do something, it will transmit this message through this to this one, the real servo. Okay. So now to control this, what we're going to do is we are going to use another property of it, which is a function called write, and what it takes as a parameter is the degree to which you want to move the servo to. So let's say the 0 degree, when the servo is in the 0 degrees, when the servo is like on a 0 degree angle, it is a closed state for the door, and when it is 180 degree, it is on an open state for the door. So what we can do is servo dot 180, write 180, which will means that it opens the door, and to close it, what we can do is servo dot write 0, and it closes the door. Okay. Now we can just hit play, and yeah, just let me zoom out a bit. Yeah. Okay, so I just tap it up here. I have the bar. Okay, so as you can see, it is on 0 degree now, right now. Like it is 0 degree right now. Okay, so and I'm on 220 centimeters. So as soon as a guy comes in and just closes down to like 50 centimeters, okay, the door has opened, right? And when it goes out, the door closes, and it can be done as many times as possible. Isn't this amazing, right? Another thing that we can do is, like, if when we begin, we want the door to always close, because there might be some chances that the door is open and it stays open for a long time. So let's just close it here. Right? This is the final simulation. Here. So this was the basic simulation. I hope you like it. I have another project for you guys which requires a bit more logic than this one. I'm trying to show you. Yeah, this one. This one is one I built earlier, and it's a random number generator, guess game, I guess. Yeah. So we hit play, and what this game does is, in this game, an Arduino picks a random number from 1 to 999, both inclusive, and it doesn't tell the players which number is it. What you have to do as a player is that you have to guess that number, and you have unlimited number of tries. In each try, if you have a wrong attempt, then the Arduino will give you feedback on whether you want to guess higher or you want to guess lower. Okay, so let's just try it. We press hash to start and continue. Okay, so I get to guess now. Let's go midway between 1 and 999, like 500. So it tells me like guess lower. Okay, so I can guess lower like 250. Okay, sorry. Yeah. Okay, So it's between 200 and 500. I can guess, like, say 350. Guess higher. So 350 and 500. Let's say 450. Okay, so 350 and 450. Okay, so 400 and 450. Okay, 425 and 450. Okay, 437 and 450. 437 and 442. Maybe we can say 440. Okay, 438. Okay, 439. Yeah, you have a correct guess. So this was a game, and this is code. Like servo.h, we are also using two libraries here, Liquid Crystal and Keypad. They also both create a virtual liquid LCD display and a keypad. You can take a look at this. The links to both of these projects will be shared along with the PPTs. So that's it for today's session. I hope you guys like it. The session is open for doubts. You can put your doubts in the chat or just raise your hand.
Excuse me, Shreyans.
Yeah.
I think Kamlesh has a doubt. He has mentioned it in the chat. He says, "Sir, how should we know the flexibility to use which pins to be connected?"
Yeah. Where is the
Like how will we get to know which pins to use and which ones to not?
Okay, in Arduino, as you can see, there are some pins with a tilde sign. Those are the PWM pins, and the rest are normal pins. And on the bottom, you have the analog pins. So depending on the purpose, like if you want to send a PWM signal, you can use a PWM pin. Otherwise, you can use any pin that you want. It's not that you have to use a one pin or two pin or third pin. You can choose whichever you want. It's just that there are different categories of pin, and you just need to choose that. Like I choose 2, 3, and 5. I could have chosen like 11 or something, anything I wanted. It was up to me. That is the reason why I have to specify the pin in my program, because it's of the flexibility. I have the flexibility to do whatever I want, right? Yeah, we searched. Yeah. I hope it was clear, Kamlesh. One more question.
I think Aditya has a question. Aditya Kumar.
I can't find it.
Yeah, Aditya Kumar, if you have raised your hand, you could just unmute and ask the question.
Yes, sir. I have doubts, sir. How we will come to know about all these coding and functions? From where we will get these?
Okay, what you can do is, like, whenever you have to, stuck somewhere, just Google it. If you don't find it, Arduino has a docs. I can attach the link. Just give me 2 minutes. It has a doc for all the programming needs that you want. Hello.